Okay, today we're going to learn about linear relations and functions, and we are going to learn of what standard form is. And this is a standard form of a linear equation. A linear has the word line inside of it. So basically, we only have two parts for today. The first part is just put it in standard form, and then we're going to learn how to graph. So this is the standard form of a line, ax plus by equals c. Let's talk about the standard form of a line. Notice that the x and y are on the same side. Does everybody see that the x and y are on the same side and that the number is alone on the right side? I want all whole numbers, and I want x to be first, and I want it to be positive. That kind of got mixed up, but x needs to be first and positive. So here are the steps. We want the x's and y's on the same side. Number two, we want whole numbers, which they are, and we want x to be first and positive. So here are some examples that we're doing here. So we want the x's and y's on the same side. So how do you get the x's and y's on the same side? We add 4x to both sides. So we get 4x plus y equals a negative 7. The only thing I did was add 4x to both sides. Okay, let's look at this. Compare this boxed one right up here, way up here, to this one right here. Does that look very similar? Is my x first, and is it positive? So my a value is going to equal 4. This is my a, this is my b, and this is my c. So my b is an imaginary 1y, and my c is a negative 7. Okay, let's do the next one. In order to be in standard form, my x's and y's have to be on the same side, so I'm going to subtract 6x to both sides. I'm going to get negative 6x plus y equals 5. Negative 6x plus y equals 5. Okay, there's something wrong with this. Let's go up and read the stipulation one more time. X and y, are they on the same side? Yes, they are, so I check that one off. Are there whole numbers? Yes. Is x first? Yes. Is x positive? No, so I need to check that off. And how do I check that off? If it's not, all I'm going to do is change everything to their opposite. So instead of a negative 6x, it's a positive 6x. Instead of a positive y, it's a negative y. And since it's a positive 5, it's a negative 5. So that's how you make x positive. If you look up here again, see I'm circling this. My a value is 6. My b value is a negative 1. And my c value is a negative 5. Okay, last one. I'm going to bring this over to there by subtracting 4x. I have a negative 4x plus y equals a negative 2. I want my x to be first but positive, so I'm just going to change everything to their opposite. Notice I changed all of my terms to their opposite. My a is 4, my b is a negative 1, and my c is 2. I think that's it for this part. I think you guys understand how to do this. So I'll do one more. Let's do one more. Let's just continue this page. Let's do this one. Okay, let's do y minus 3x plus 2 equals 0. Okay, my y and my x are on the same side, but I have to get rid of the 2, so I'm going to subtract 2. So I've got y minus 3x equals a negative 2, because I have to bring that over to the right side. I need my x to be first, so I'm going to rewrite it. So it's a negative 3x plus y equals a negative 2. But then I want my x to be positive, so this changes to positive. That means this changes to negative, and that means the other one changes to positive. A equals 3, B equals a negative 1, and C equals 2. So hopefully you understand it after 4 examples. Now comes the second part of the assignment. Why is it good to have it in the form of AX plus BY equals C? Because we're going to learn how to graph them. To find where it crosses the X, and you're going to make yourself a chart. Make yourself a chart, and there'll probably be a chart on the test. You're going to let X equal to 0, and you're going to let Y equal to 0. You only need 2 points to make a line. So what you're going to do is you're going to go up in here and you're going to replace the X with the 0. And what happens when you replace the X with the 0? What is 2 times 0? Doesn't all this cancel out? So what are you left with? 3y equals 12. 3 times what would equal 12? Doesn't 3 times 4 equal 12? So doesn't y need to equal 4? And then we're going to erase it. And I'm going to do the same thing with the other one. My y is equal to 0. So I'm going to go up here and replace my y with 0. 3 times 0 is 0. See, all that's gone now. The only thing you have left is 2x plus 12. 2 times what equals 12? 2 times 6 equals 12. Now the last thing they want you to do is to graph it. You're going to go 0 and 4. 1, 2, 3. You're going to go nowhere on the x-axis and go up the y. Remember, this is the x-axis. This is the y. Here, you're going to go out on the x-axis 6. 1, 2, 3, 4, 5, 6, and go nowhere on the y-axis. Those are called the x-intercepts and the y-intercepts. And then all they want you to do is to connect your dots to make your line. So let's do one more. I think we have another one, don't we? Yes, we do have one more. So when you get to these problems, I want you to make an X and a Y chart. I know you guys can make an X and a Y chart. And I want X to be 0 for 1 point. And I want Y to be 0 in the second point. Now all I'm going to do is I'm going to replace my X with the 0. And that's going to cancel all of this out. You're going to say, what a negative 4 times what would give me a 12? A negative 4 times what number would give me a positive 12? Doesn't it have to be a negative number to make a positive 12? Doesn't a negative times a negative equal a positive? Doesn't that number need to be a negative 3 to make a positive 12? Okay, let's do it again. Let's just go back. And let's do the same thing. This was a negative 3, remember? I'm going to let my y equal to 0. So if my y is equal to 0, all that's gone. 3 times what would give me 12? 3 times 4 will give me 12. Remember that this is the x-axis and this is the y-axis. I'm going to go nowhere on the x-axis, but I'm going to put my y-intercept at a negative 3, which is down here. I'm going to go out on the x-axis 4. And I'm going to connect my dots. You're doing it right if your dots are landing on the axis, and that's why it's called the x-intercepts and the y-intercepts. So you're doing it right if your dots land on the axes.